In this session, we're going to talk about the anatomy of a Spark job. We're going to look at how clusters are typically organized that Spark runs on. And this is actually important. It's going to come back to the programming model once again. You can't just pretend like you have sequential collections that are on one machine. You actually have to think about how your program might be spread out along the cluster. So let's start with a simple example to try and motivate this. Let's say we have a case class person. It's got a name, which is of type string, and an age, which is type int, okay? And let's say we have an RDD full of these person objects. So we have an RDD called people. Now, if we say people.forEach and we print line, so we just want to print out all of the people in our RDD, what happens? I'm going to give you a minute to think about it, or maybe even to look back at your previous notes. Actually, before answering that question, let's look at a second example. Assuming, again, we have an RDD full of these person objects, and I say people take 10, what happens? Where will the array of person objects that is returned by take 10 end up? I'll let you think about this too. Before I give you the answer for both examples, let's first look at how Spark jobs are executed. Spark is organized in a master-worker topology. Remember, you are writing a program which is then getting distributed to a bunch of workers where your data is, and typically roughly the same operation is being done across all of the workers. So usually there's one master and many workers. In the context of a Spark program, we refer to the node that acts as the master as the driver program, and we refer to the workers as worker nodes. Now, the driver program is where this Spark context is. So this is the thing that we are using to create new RDDs, to populate new RDDs. So when we do Spark context or sc.parallelize or sc.textfile, we're actually using this thing here in the driver program. When you write a Spark program, you write a Spark program from the perspective of this node here. So you think as if you are the driver node and you're giving commands to worker nodes. So this is the node that you're interacting with when you're writing Spark programs, and these are the nodes that are actually doing the jobs. So the executors are actually doing all the work, and this is coordinating the work. You can think of it that way. But of course, how do they communicate? They communicate via something in the middle called a cluster manager. And a cluster manager is what actually does the work of doing all of the scheduling and managing resources across the cluster. It keeps track of everything. It does a lot of bookkeeping. Popular cluster managers are Yarn or Mesos. So often when you're running on a real big cluster that you're maintaining yourself, you typically choose one of these cluster managers to run on top of. Okay, so this is more or less the anatomy of a Spark job. So you have this driver program, you have your Spark context in it. All of it is kind of passing through this cluster manager thing that takes care of stuff like memory and whatnot. And all of the work is being done in these things called executors on the worker nodes. So when you take a step back, it's best to think of a Spark application as a set of processes that are running on a cluster where the driver program, the driver node here, the master node, is coordinating all of these processes. And it's important to remember that the driver is where the main method of your program runs, and the process running the code that creates the Spark context, it creates RDDs, and it stages up and sends off transformations and actions, that all lives here on this driver node. So the driver node or the driver program is really the brains of your Spark job. So these processes that make up a Spark application, these are all running in these executor things here. And this is also where your data is stored and cached. So just to summarize, executors run the tasks that represent the application. They return the computed results to the driver. So whenever an action is done on one of these executors, the executor is the one that returns the result back to the driver program. And of course, executors also provide in-memory storage for cached RDDs. So to summarize the steps that represent the execution of a Spark program, the driver program runs the Spark application, which creates a Spark context upon startup. Then the Spark context connects to a cluster manager. For example, like I said, the most popular are Mesos and Yarn, which then allocates all of the resources everywhere. After that, Spark acquires executors on nodes in the cluster. So now that you have a few nodes and you have this cluster manager running, then you establish executors everywhere. And these executors are the processes that run computation and store data for your application. Next, your driver program then sends your application code to the executor. So the driver program is actually sending code around. Think about it. You're sending a function around to the individual nodes here. So if I want to do a map on an RDD, this guy is actually sending that function to all the individual worker nodes and saying, hey, apply this function to the data that you have on your node. And then, maybe there's an action and then send the result back to me. And finally, the Spark context sends tasks for the executors to run. So the Spark context figures out what to do and then sends it along to the executors to actually execute that work. So let's go back to our first example, now that we know a little bit about the anatomy of a Spark job. So remember, we had an RDD of these person objects. We did people.forEach print line. So the question was, what happens? Well, on the driver, nothing happens. Why might that be? I'll give you a hint. For each is not a transformation. Remember that for each is an action, and it has return type unit, so it's a side-effecting thing. Therefore, because it's an action, it's eagerly executed on the executors, and it's not being executed on the driver. So any calls to print line that happen inside of this for each thing end up happening on the individual worker nodes. So then whatever this print line is doing is being executed on the worker nodes, and it's going to the standard out of the worker nodes, which you can't see if you're looking at the standard out of the master node that you're on. So basically what this does is it prints lines on the workers that you can't see because you're sitting on the master. Okay, what about this? The second example here. So what if we have this RDD of people and we do people.take? What happens? Where will the array of person representing first 10 end up? Well, by now I think you'll guess the driver program, because in general when you execute an action, it involves communicating data back from the worker nodes to the driver program. So what you do here is you're telling the executor nodes to do this computation and to send it back to the driver nodes. So running an action actually sends data back to the driver nodes. So what you're doing is you're giving an order to the worker nodes to do some work, and then the work nodes are sending their data back to the driver node. So the driver program is the one that has this array of 10-person objects. So the moral of the story is to make effective use of RDDs, you really have to understand a little bit about how Spark works under the hood. In particular, you have to know the anatomy of a Spark job. You have to know that there's something called a driver program, and that's sort of the brains of the application, and that a bunch of work is being farmed out to worker nodes and executors all over the place, right? And due to this API, which is mixed, eager and lazy, it's not always immediately obvious upon first glance which part of the cluster a certain line of code might run on. For example, transformations. So transformations are queued up, and then when an action comes along, then all of that stuff that got queued up gets optimized by the driver program, sent to the worker nodes, and then the worker nodes send something back to the driver node. So when you write a line of code like for each, you really have to think about where that code is going to execute. If you write for each and you want to do some for each print line to see what is going wrong with your data set, you're not going to see the result of that because that's being executed on the workers. So you really got to think about where your code is executing. It's on you to know where that code is executing. So remember, even though RDDs look like regular Scala collections upon first glance, unlike Scala collections, RDDs require you to have a good grasp of the underlying infrastructure that they're running on. That's the takeaway for this session.